Yes.
Hi guys, my name is Sharoz Nadeem Abbasi and today I'm working with my friend Fong Tiran and today the topic of our discussion would be concrete. So as you guys might know, there are a lot of construction sites and industrial areas in Melbourne, all over Australia where concrete is manufactured, transported, and there are a lot of various testing systems required for concrete. So the problem is that a lot of the new employees, when they get employed to a construction or a working site, they don't have the basic knowledge about concrete. So today, basically, we're gonna be talking about telling you about some basic knowledge about concrete. So starting with concrete, the basics about concrete. What basically is concrete? Concrete is widely used in domestic, commercial, recreational, rural, educational construction. Communities around the world rely on concrete as a safe, strong, and simple building material. It is used in all types of construction, from domestic work to multi-story office blocks and shopping complexes. Despite the common use of concrete, few people are aware of the considerations involved in designing strong, durable, high-quality concrete. Concrete basics aim to provide a clean, concise explanation of all aspects of making quality concrete from the materials and properties involved through planning, preparation, finishing, and curing. So the first thing we're going to be talking about is structural basics about concrete. So to understand comprehensive strength, think about several packs of crackers sitting on the floor. If you carefully stand on those crackers, your weight will probably be spotted, and you're putting those crackers in compression. Your weight tends towards crushing those crackers. If you jump up and land on those packs of crackers, you will increase the force applied and probably crush the crackers. You will have made the crackers fail in compression. All right, so next we're gonna be talking a little bit about processing of concrete. Of course, for a very small concrete projects, concrete can be mixed on the job site by hand or in portable concrete mixers. It's important to understand that concrete mixed in this way is unlikely to be uniform as ready mixed concrete due to the variations inherent in the process. So what are some of the variations that you should be careful about while making these mixtures? Measuring, often done by shovels, will be much less precise. As you know, like shovels, they're not like a measuring instrument or anything like that. So the measurement that you're gonna be taking with shovels is not gonna be precise or more accurate. It's gonna be a little bit less accurate. Moisture levels in sand and gravel will be unknown. Third thing, the concrete cylinders that are made to determine the 28-day strength can also be broken earlier and provide useful information. Cylinders are commonly broken at 7 days, which normally have developed about 75% of the 28-day strength. It's nice to know 3 weeks earlier if there is a problem with the concrete bed. So basically what this does is that when you're making a concrete mixture, you can even test it 3 weeks before the day when it's completely made. So that way you can know about the mixture, that is it like the work that you're doing is right or not. Breaking cylinders at 3 days can also yield useful data. If a spotty slab has been placed, the 3D concrete breaks can be used to determine if stripping or the forms and supports will be safe. So concrete cylinder breaks, when it breaks, provides a number of useful bits of information. The basics of making the cylinders should be understood by the construction supervisor. I'm gonna just repeat this once again, which is a very important point. The basics of making the cylinders should be understood by the construction supervisor. When the wet concrete is being placed, cylinders 6-inch in diameter and 12-inch high are filled with concrete and carefully consolidated. These cylinders then cure, hopefully in conditions similar to the curing conditions for the main concrete pour. The concrete cylinders harden in a few hours and are stored for future testing. That testing consists of placing the cylinder in a machine that presses on the cylinder top and bottom, adding axial force until the cylinder crushes. This is basically a whole process of how you make the concrete blocks and cylinder using the cylinders. All right, third thing we're gonna be talking about is the quality control before concreting. It's a very important thing about concreting, and it's basically done in three stages, distinct stages. So first stage involves quality control before concreting. Second stage involves quality control during concreting, and the third stage involves quality control after construction. So for the first stage, quality control before concreting, there are a couple of things, there are a couple of steps that you should be aware of. Number one would be checking of specification requirements regarding excavation forms, reinforcement, and embedded fixtures. Control tests on concrete ingredients. Example, cement, aggregate, and water. So cement, what basically is cement? Quality of cement is ascertained by making comprehensive stress tests on cement cubes. There are things that should be taken care of about cement. That number one, should be tested initially once for each source and subsequently once for every 2 months. Number two, should be protected from moisture. Number three, should be resetted after 3 months of storage if long storage is unavoidable. Should be rejected if large lumps are found in cement bags. Aggregate. Concrete aggregates should conform to specified values as per standard specification. The quality of concrete is affected by different physical and mechanical properties of aggregate, that is shaping, grading, durability, specific gravity, and water absorption, etc. These properties aggregated should be tested before using it for concrete production. The quantity of deleterious materials and organic impurities should also be tested. Bulking of sand is also an important property in several ways. It gives wrong results when volume batching is done. It increases water content ratio and in turn reduces strength. For effective control aggregates, number one, it is required to be tested once initially for approval of source. Number two, should subsequently be tested once or twice for moisture content, and allowance should be made for moisture content of aggregates. Number third would be water. The quantity of water should be checked for the requirements as specified in respect of water. I would say it's a very important tool for making for manufacturing and processing good quality of concrete. Chemical analysis shall be conducted for approval of source. In case of suspended impurities, it is necessary to store water for some time to allow them to settle down. All right, the stage two of manufacturing the concrete would be concrete control during concreting. All right, careful supervision during concrete manufacture is necessary for all concreting operations, such as batching, mixing, transporting, laying, compacting, and curing. Following precautions should be taken before concrete operation. Third stage, concrete control after construction. So once the concrete is laid and compacted, compression tests are made on the cubes made out of the concrete. For ordinary concrete, cubes are made of the concrete made at work site. So now I'll be talking a little bit about some of the various testing requirements done for concreting. So there's a test known as the slump test that is usually done for concrete, various testing requirements for concrete. So what usually this test consists of is slump test is done to make such a concrete mix that is workable. The measured slump must be within a set range or tolerance from the target slump. So there are some tools that are used for this slump test. The tools that are used in the test are, I'm just gonna name them. Number one would be standard slump cone, that is 100 millimeter top diameter into 200 millimeter top diameter into 300 millimeter height. That's basically the you can say the different values given about the diameter and the length and the width about this slump. Small scoop. Number two is small scoop. Number three would be bullet nosed rod, which should be 600 millimeter long and 16 millimeter in diameter. Number four would be a rule. Number five would be slump plate 500 millimeter into 500 millimeter. That's like a square size for this one. Method. All right. So the method that is used for this slump test is that clean the cone. First step is clean the cone, dampen with water and place on the slump plate. The slump plate should be clean, firm, level, and non-absorbent. Collect a sample, see sampling. Number three would be stand firmly on the foot pieces and fill 1/3 the volume of the cone with the sample. Compact the concrete by rodding 25 times. Rodding, what is actually rodding? So rodding means to push a steel rod in and out of the concrete to compact it into the slender or slump cone. Always rod in a definite pattern, working from outside into the middle. Now fill to 2x3 again and 25 times, just into the top of the first layer. Fill to overflowing, roding again, this time just into the top of the second layer, top of the cone till it overflows. Level of the surface with the steel rod using a rolling action. Clean any concrete from around the base or top of the cone, push around the handles and step off the foot pieces. Carefully lift the cone straight up, making sure not to move the sample. Turn the cone upside down and place rod across it. Take several measurements and report the average distance to the top of the sample. If the sample fails by being outside the tolerance, that is, slump is too high or too low, another must be taken. And if this fails, the remainder of the batch should be rejected. So this is basically how you conduct a slump test. Now there's another test that is used for various testing requirements for concrete, that is known as the compression test. So what does this test conclude is the compression test shows the compressive strength of hardened concrete. The testing is done in a laboratory off-site. The only work done on site is to make a concrete slender for the compression test. The strength is measured in megapascals, that is MPa, that is the unit used to measure for the used in this test, and is commonly specified as a characteristic strength of concrete measured at 28 days after mixing. The compressive strength is a measure of the concrete's ability to resist loads which tend to crush it. So it's a very important point that what is a compressive, if someone asks you, let's say, what is a compressive strength of a concrete? It usually is a measure of the concrete's ability to resist loads which tend to crush it. So now the tools that are required for these tests are cylinders that should be 100 millimeter in diameter and 200 millimeter high, and 150 millimeter diameter into 300 millimeter high. That's usually the measurements used for the cylinders. Number 2 would be small scoop. Number 3, bullet rods, nose rod. That is, of course, that was also used in the slump test that I just described before. Number 4 would be steel float, and number 5 would be steel plate. The method: clean the cylinder mold and coat the inside slightly with foam oil, then place on a clean, level and firm surface, that is the steel plate. Collect a sample, see sampling. Fill 1/2 the volume of the mold with concrete, then compact by rodding 25 times. Cylinders may also be compacted by vibrating using a vibrating table. Concrete basics, concrete testing. Fill the cone to overflowing and rod 25 times into the top of the first layer, and then top of the mold till overflowing. Level of the top with the steel float and clean any concrete from around the mold. Cap: clearly take the cylinder and put it on a cool dry place to set it for at least 24 hours. After the mold is removed, the cylinder is sent to the laboratory where it is cured and crushed into test compressive strength. So this is basically how the compression test works. So basically we have just described 2 tests, slump test and the compression test, that are used for the various testing systems used for concrete. So another thing I'll be telling you guys is about the transport and the handling of the concrete. As you know, concrete could be a very, very heavy material to be used. So usually in the worksite areas there are special uniforms, and of course there are a lot of other materials like safety shoes and stuff like that that are used to and there are a lot of other actually machines like the forklift and these kind of stuff that is used for moving concrete within the site, and for moving concrete within the stays, or you can say for different various size out of the working size, different bigger trucks and stuff like that is used. And yeah, concrete, as I said before, is a very heavy project and should be handled with very carefully. So this was basically today's our small kind of presentation that I just gave it to you about concrete. So basically what I told you was how concrete is manufactured, processed, how it is transported, different types of various testing systems that are required on concrete. So yeah, that's all for today from me, Shahroz Abbasi, and from Turan, and see you next time. Thank you.